Hello, everyone. Welcome to the Dagger community call. We're going to get started in just a moment. So fill up your coffee, do a quick bathroom break, and we'll be right with you. Hello, everyone. Welcome to today's community call. We really appreciate you all taking the time to meet us today. If you are on YouTube, and I believe it's on Twitter as well. If you are watching us on LinkedIn, the quality is better on YouTube if you're there. But we do have LinkedIn streaming for people just in case they can't access either of those other platforms on their work computers. But we'd love to know where you're watching from today. So if you want to go in the comments and let us know where you're watching from, it's always fun to see where everyone is located. And if it is your first community call today, I just want to go through a quick reminders. So on YouTube, it's super easy to add comments. So add as many comments as you'd like. But we also use our Discord channel, the general channel, to allow people to add comments there as well. So if you aren't already in our Discord, it's a great place to be, especially if you're trying out Dagger, because it gives you the ability to chat with our whole team, but also all of the amazing Daggernauts and Dagger commanders too, who are always willing to help. And if you're watching this and you want to submit a topic, just like our folks here, just reach out to me on Discord, just Miranda Carter, and I'm happy to get you on the schedule. And so let's go into introduce ourselves. So who do we have on the panel today? Patrick, do you want to go first?
Yeah, sure. I'll go first. Hey guys, I'm Patrick. I'm one of the commanders for Dagger. So I'm a software developer. I'm kind of engineering lead, and I kind of work in the chemicals commodity trading space with gas, oils, and things like this. But my demo today is actually going to be completely unrelated to things to do with work and more about a hobby project. But yeah, my background is usually C# programming, things like that. So yeah, that's me.
Awesome, thanks. And Yannick?
Hi everybody, I'm Yannick. I'm from Puzzle ITC, a Swiss company. I work there as a platform engineer, and I'd like to show you our Dagger engine hosting journey today.
Awesome, thank you so much. And Sam?
Hi everyone, Sam Alba, co-founder of Dagger, and today I'll show you a quick demo to how to use GPUs from a Dagger pipeline, basically running an engine on Fly.io. So
Awesome.
excited to show you that.
And I think we have a question on the GPUs every community call for the last 6 weeks. So everyone who's watching that asks those questions, I hope this demo is helpful for you. And Kyle, how are you doing? Who are you?
Yeah. Hey, I'm Kyle. I'm on the ecosystem team at Dagger, and I'm your co-host today.
Awesome. Thank you so much for helping out and joining. So as people are throwing in questions while we do the demos, me and Kyle will kind of be monitoring those. So feel free to add any commentary or any questions, again, to our YouTube or our Discord channel. So I think, let me add this back to the stage to remind me who's going first. So Patrick, I think we have you going first. So let me add you to the stage. There we go. And go for it. Just update the sizing a little bit.
Yeah. All right. So I'll just kind of give some background around this whole project, really. So I've made a couple of projects in the past which are kind of around a little helper tools for a game or a community that I like, right? So if it's Star Wars, I might kind of make a tool around that. If it's Diablo, maybe I can make a tool around that. If it's another game like Dota, maybe I can make a little tool around that. Generally, it's something that I do when I'm kind of playing a game with a friend, or I just want to learn something new, and I try and pick something that's kind of related to gaming because it's just kind of a passion I have. And I just thought, well, maybe I could use a bit of Dagger just as I was developing this application. So it's a Windows-based app, but Avalonia is a cross-platform kind of framework you can use. So if you know C# and you want to build something for a Mac or for Windows, you can use their framework, build it, and you can have a nice looking UI. So I've used Avalonia, kind of like, that's what I've picked. And what I'll do now is I'll head over to my little project. It's running in Rider. So Rider has a cool kind of like plugin where you can visually see your Avalonia app as you build it with XAML. But this is kind of like how every Avalonia app kind of starts. Like you'll get a default template, you've got your Avalonia, like whatever it is, like a default hello world. And so this is kind of like your main input. And so with the with a desktop app, right, you're going to have views of some kind. So what I can show you is just kind of like, what is it that kind of like I'm building visually, like as an app, as a tool. And so what this tool is, this Dota helper, is a timer-based app. So it's integrating into Dota by using something called game state integration. And there's a little config file that you can basically place into your game installation. And the Dota engine, I think it's the Valve engine, the Valve engine, will send requests basically, right, to this endpoint that you've said, giving you some information about the game. I'm not using too much information from the game that's running. It's only using like basically the time of like what the game time is at that moment. But I might add more things into the future. And so, yeah, this is kind of like one of the main parts of the app, right? Like you're going to have someone who's going to launch the app. They're going to want to maybe make some timers. They might want some timers if they're playing like a healer or a support or a tank, like kind of depends what their role is in that game, but they might just not be interested in all the kind of timers that you get with the app. So there is that kind of customization where they can create profiles. And so, yeah, this is all built with XAML and C#. So let's go to the timers view. I guess this one's kind of important. So the timers view is actually the one that's kind of the most used. This is like an overlay. The overlay is like a little transparent window that pops up and it will show the user, including like audio clues, of when something's about to occur within the game so that they can go, okay, I need to go and do this like little objective, right? I forgot how to do this thing. I need to go and stack this camp. I need to go and probably go and gank top lane. The boss is up, right? Any kind of timer. This will kind of like help them a little bit. So I wouldn't say that this is for like advanced users. This is really a training tool because it's quite an overwhelming game. Dota is very complicated. So it's just a tool there to kind of help. So yeah, this is kind of all the main screens. There's not that many screens, right? You've got the settings, you've got the profiles tab, the timers tab where they can add in timers or default timers. There's an integration tab where they can essentially just make sure that all the configuration is running, like, hey, the game is installed, hey, the config is right there, hey, I'm listening for events to be sent to the app, right? Because the game will be running, it's in and like basically start sending like these interval messages to the client. Which is like a little mini web server, basically, that runs in this app. And so that's how I can kind of keep these timers calculated, right? So there's some C# that I've got here. And basically every second, this is like going to be getting some new information and calculate some stuff like what timer should be visible. Should the timer now be hidden because you don't want all the timers always running all the time? So there's some maths in here and some stuff to do with times and the seconds and making sure that it doesn't show everything or too little. And yeah, so that's like the main app part, right? What I can show also is just the config file, just to kind of give you a concept like how does that thing work. So this is the little file that gets put into the game, like game state integration folder, and it's just basically telling the game engine, hey, send your information to this local address, and I'm only interested in map data. Like I don't care about any information about the players or what abilities they're using or any items. I just care about the time, basically. That's really the most important part for the timers. And so yeah, that's kind of the main piece, right? So kind of show you just if I run the app locally. This is the little splash screen that I've got that kind of comes up, and we'll click this and it just kind of starts it. You'll see in the top left corner, it's very faint, but that's a little overlay, and that can go on top of the game. And the idea is that as the game is running, different timers will appear. Now, they're not appearing right now because it's -1 minute when the game starts, but if I was to just add another profile quickly, let's just add some kind of fake timers in, right? Just enable these instantly. What you'll see is just that's kind of like how the timers appear for the user, and they can give the timers a custom name, like, oh, this is for this bounty rune, oh, this is for something else over here. And as long as they know when that event occurs for that specific timer, they can configure the time of when that should fire. They can configure if they want an audio file to play for that timer. And yeah, that's kind of the main part of the game, right? The main part of the app. So the reason the time's working now, I'm not actually running Dota. I don't have it open, but it's really nice to be able to configure the timers to make sure that they do what they should. So I have this kind of like demo timer, game timer, and auto. So if the app detects the game's running, it will swap and make sure that it's actually using the real time of like the game. But just whilst the game's not running, you're just running the config, you just got the app open, you want to test everything that's showing correctly. It basically just fakes the time, right? So it just kind of creates a fake time. And so that's the app. And I was thinking, well, like none of this is really like Linux or containers or Docker, like you're running a Windows app. Why is Patrick using Dagger at all for this? There's a few little pieces, and I think I'll move on to that piece now. So yeah, let's show you the Dagger stuff that I've got. So let me move over to my Golang IDE. So it's in the same repo as all the source code of the C# stuff. It's just as a separate IDE, just so I get the IntelliSense. And here is my my module. It's a private module. It's not to be used for anything else. It's just for like my mini project here. And the app is cross-platform in some ways. I haven't built it to be like tested on a Mac, but I'm sure I could make sure like kind of improve it and make sure that it could run on a Mac. But it's really just using .NET SDKs under the hood. And .NET SDKs, there's base images for that, right? So I've managed to pull down the Microsoft's .NET SDK version 8, which is the current LTS version. And there's a couple of NuGet packages and some tooling that I use as I build and bundle the app. So I kind of also am able to install those too. So even though it's a Windows kind of like main thing that I'm building, I can still actually use Dagger to make sure that my app is like using like the correct SDK. I can run it in a CI pipeline without needing a Windows agent. I don't need any of that stuff, right? I can just have, hey, look, it's going to run on a simple Ubuntu machine on a GitHub action. And so yeah, this is kind of like me building out my main, like just my environment with two tools which I kind of use, which help me with some specific information that isn't part of my build time that I want in my pipeline. So I can give two examples why the Dagger piece with the building is cool and nice, but also why did Patrick also need Dagger? Well, there's this NuGet license feature, which I thought is really nice to have in a pipeline, and also this Git version tool. So the two pieces that they link to, if I launch the app back up, you'll notice I get a little version here, like version 1.41. That's one piece which I use just with tagging, like when I do a GitHub release. And the other piece is there was that other tool which I showed, which was like Git license versions. When my app is building, I get some NuGet packages. So like any shared packages I have, they get restored. And I have that .NET tool scans the NuGet packages that are in my app, and it creates a JSON file. And that JSON file I'm parsing to make sure that any like third-party packages I've used in my project, I basically just have them listed in the app. So rather than me having to run that tool manually every time I do a build or I add a new package in or I push stuff up, oh, that JSON file is like not being automatically handled. So to make sure I don't miss that step, when I push my code out, I want to make sure it runs some .NET tool specifically with that like build and release process. So it can always create the most like freshest JSON file with those packages. And so, yeah, this is a nice way for me to make sure that, you know, I'm linking every project and that like the license that's with them in the app. And so I'm not using too many things. One is for audio. There's like a cross-platform like audio library used just to like run the WAV files or the MP3 files that users configure. And another one is for reading like Valve domain-specific key value files. So this file doesn't really look like a JSON file. It's a Valve-specific file. And so just to make sure that they're contributed properly in the app, I've just made sure that that's kind of included, right? So yeah, that's why I install these two tools. So that's the main piece, really. It's like, okay, let me just get my my main image. And so when I want to make sure that my licenses, like that JSON file is actually correctly configured, I have this get packages file, which is a separate function, which is actually using that tool I've just installed, right? So this is, again, a separate function. I just want, what's nice about Dagger is I can have all these little pieces, all these mini tasks that I know I need as separate functions. And then I can just compose them later on into the main function that I'll use in like a pipeline, like a publish or whatever it is. So in this piece here, what I'm doing is I'm adding in my Git repo, doing a .NET restore to make sure all the packages are restored, and then running that tool. And that outputs a package.json file for me, so I know it's the latest one. And I just kind of grab that file back, and I can place that into my actual distribution later on. So that's one piece here, which is pretty useful. And then the version, so that's using Git version, where I basically can grab the right version information so that I got that for my release zipped file name when I do a GitHub release. So that's another piece, which is what I'm using. Now, what's another main piece here? So my .NET publish. So yeah, what I'm doing here is I'm getting that container. I'm adding my code in. I need to close this because it's actually bringing up audio. Yeah, so I add my repo in. I make sure I mount that packages, which I was talking about, into this build stage. I .NET publish. This is the name of the repo, that the project that it should be building, because I've added the code in, right? It's targeting for Windows 64, just at least for this specific like support that I have. I don't have a Mac to really test on. Then I've got this self-contained, so I just kind of like want everything to be bundled, if it can, into one thing. And so that's the last piece, right? That's my publish. So what's nice is I can run this, and I know if it's actually going to be doing everything I need locally without having to run it in a separate place. I can just do this locally. And then I've got a publish zip. This is using, I think, Mark, one of the other commanders. He wrote two modules, which I pulled in because they were actually really useful. And one is zipping things up, and the other is actually doing the GitHub release, right? So these two other functions, which I kind of like make use of, I get my .NET published output, and then make sure that I'm just getting the published folder, right? That's all like the DLLs and everything that come with the app. I zip them up using that shared module, and just give it like the naming convention that I kind of want, right? This is kind of like how it should be. This is the version. It's Windows, AMD 64. Zip it up, and then that's also my kind of publisher's zip done. So now I can run that locally, and every time I run that, I know I don't have to like wait and run that in a CI pipeline with some custom stuff. I can just run this locally, make sure I get the zip, even unzip it locally, test it, which is really nice. And then I've got my main piece here, which is the release. So this is really the only function that's, I guess, the most important out of everything, because this is the one that just does the whole thing. So yeah, I'm using my zip function, which was kind of written above, right? I've got this publish zip. That means I get my zipped app. I get some version information using Git version, just so I can actually do the release naming in the GitHub release properly. And then that's it. That's the main piece there. I then use that shared module, which I've installed. I pass in my options, do a release, do a create, pass in that information, and then that's my release done. So this is actually really nice. So the way that this runs, at least for me, is really simple with two kind of workflow files I've got. One is, so this is the way that I've set it up. I don't know if this is necessarily perfect or like the best way, but I've set it up so that when I tag something, even from my local machine, like git tag version like 104, right? If I push that, that's when I want it to do the release. I don't want it to like click a button on GitHub or do anything else. So I've basically just said, like, when you get a tag that's pushed, that's when you should be running that command that says, yeah, do the release, basically. So it will call that release function. I pass in my token, and then that release will then send the actual release to GitHub, right? So when I run that, I get my nice output in here, which is under releases. And you can see like this is currently the one that I've got. So 141. But yeah, that's how I get the naming of my releases here.
Nice.
So that's pretty nice.
And
Is that all making sense so far, guys?
Yeah, no, it is actually. I was actually just looking at how short that YAML file is, but how much it was doing. It was,
Yeah, well, I mean, this one's
it was
yeah,
31 lines or something.
yeah, so my release is really, really simple. Like that's the only YAML I really needed for my release, right? Everything else was just all those other functions that I can run locally. Yeah, and my build, yeah, it's not really just, it's doing pretty much the same as a release, just without publishing it. So I still like to like run any tests, actually make sure the build is working. Again, really simple, really, really simple YAML. I just didn't have to write that much, and I don't want to,
Right.
and that's why I really like this this stuff. There's another thing that I've actually got that I didn't actually include in like the main pipeline. So I have some functions that I only use locally, and I just thought that's probably quite important to share. Like you don't have to have only functions that you would just run on like a CI platform.
Right.
So I've got a use case here, which could be pretty good to show. Now the app comes with some bundled audio, like specific audio files for these specific objectives that can happen, like when a power rune spawns or a tier 5 tier neutral. There's these specific objectives. And it was kind of really annoying to like go, oh, like where do I get these audio files from? What app online can I use? Oh, are they expensive? Which one? Blah, blah, blah. And I don't want to regenerate these all the time, but I wanted a way to like just quickly go, there's this new objective. I'm going to add it in, and oh god, what was that thing I did when I needed that MP3 file created, and then go doing it manually? I didn't want to do any like mini manual tasks. So what I wanted to do is try and find any task at all that I could automate if I needed to do it again, despite it not having to be part of my release pipeline, get it in a Dagger function. So this actually happened. I missed out a couple of objectives just because I don't know the game that much. And it was actually useful. I went, oh, actually, I could add in the tiers really simple. And so I've got a Dagger function, which, if I go to it, it's in here. I think it's just called like create TTS. I mean, I've got it listed here, right? If I do my Dagger functions here, you'll see there's this create audio assets. Yeah, that's the one. So yeah, in here, I've got a simple function where I pass in my Open API key. So I basically decided to use OpenAI because they have a really simple TTS service to use, and the audio sounds really nice. Like you can try like Google Audio and these other ones, but this one was so nice. And so yeah, I listed out all of the audio files that I actually need. I could probably make this smarter so that it doesn't regenerate things based on what I already have. But I haven't done that. I'm a bit lazy. So that's probably something I'm probably going to add in once I've done with my demo. But yeah, I basically list out all the things I want. I create a container that gets curl because I'm just using really raw way of the OpenAI requests. Basically, I don't need a Python SDK. I just need something really simple. I pass in my key. I tell it a directory that I kind of like want the audio created in. That's a really simple template where the model name is TTS1HD. So it's like really nice, crisp like audio. The voice, and then I just loop through my assets and basically send off a request saying, hey, I want an audio file that says this. I want an audio file that says this. And so it creates all the files that I want. I get a build, I sync it because I don't really want the container. I don't need the container or anything else. So I just kind of like force the evaluation of the engine right here within that function, and then just return the directory of the audio files. So that's something that I only run locally, so that if I know I need to add something into my actual project, into the assets, into the audio file, I can just kind of do that whenever I want, and I don't have to go like finding something, right? So that was a really nice, I think a nice piece is finding something that is like really annoying or just is an asset that you can regenerate and just run those functions locally, right? You don't need to only think about something about a pipeline that's like for deploying or releasing. Like you can do these little things too. And so yeah, I think that's everything covered. So yeah, I've kind of like covered the function I've created. I've shown the publish, which is pretty simple to do. Yeah, that's 2 simple workflow files for me. Really not that complicated at all. Really easy to do. And then, yeah, I just kind of, you can download the app. It's a zip file. You unzip it. When you unzip it, that's kind of the app you get, right? You get that startup. And that's it.
That's really cool. I'd love to see it in the .NET SDK someday.
Yeah. Yeah. Yeah, I was thinking if there were some things that I could have done maybe a bit better if I was just using C# for like the Dagger stuff. But to be honest with you, once you know the way that the Dagger SDK works, it doesn't really matter what the language is. Like like you're a bit more comfortable. But I do have a case where I did a bit of Go code in another project that it was just a function, and like there is some really nice things where I wish I could write that in C#, but it wasn't like essential. Like if you just want to like really like your main concerns are pipelines and things like that, honestly it was so nice to just get away from C#. That was like my main language for like 10 years.
Yeah.
And so when I started looking into Dagger and going, oh, actually, like Go's not that complicated. Oh, back to pointers. Here we go. Oh, actually, it's not actually that complicated either. Really nice to use. So yeah, I kind of like mixing things now. So I kind of do a bit of C#, trying to learn Go. I get by with what I've got here, and it's been really nice. The project is working great, and every time I do a Git tag, Dagger's there with me, right? It's helping me push out my releases to GitHub smooth, or these little mini tasks, and it's pretty fast as well when I do the builds. Yeah, so I think that's it. I mean, I can show you the app one more time, just so you guys can see kind of like what happens.
Yeah, this is really cool. And I want to make sure we have enough time for the other demos too.
Yep.
But at the same time, I'm so excited I just want to say thank you for volunteering to come on today, but also showing this, because I think sometimes we get lost in like trying to show these larger pipelines and how those can get changed with Dagger. But like the fact that Dagger can be used every day for work things, but then also for things like this, your hobby of just making life simpler.
Yeah.
It shows everyone kind of a simpler way to start thinking about like how can you use functions for everyday purposes for anything, and just Daggers, I think you just said it earlier, like Dagger's just right with you all the time, and that's what we're aiming to do is make life simpler for any use case that a function would make sense for. And in most cases, a function anything can really be a function. So that's it's really cool to see examples like this. So thank you for showing it.
Yeah, let's go in for Deadlock now.
Right.
Oh yeah. Yeah, that's another one on my list. I'll see what I can do.
And
Perfect, thank you.
Patrick, if anyone wants to look at your code for inspiration or the functions, is there a link that would be best to kind of share with people on the chat?
Yeah, I can paste this in the chat.
Perfect.
I think I need to join chat here and connect up. But yeah, I can paste that.
No worries. Okay, yeah, no, and I can grab this too. Yeah, I just wasn't sure. I didn't check if it was a private repo before. But awesome. Great. Yeah, thank you so much for showing this.
Thanks, guys.
And I know just for the sake of time, otherwise I honestly could be asking you even more questions, Patrick. Sam, do you want to show off your GPU demo?
Yeah, absolutely.
Add you to stage. Or actually, do you want me do Inception? There we go. Perfect.
Yep.
Go for it.
Does it work now? Great.
Yep.
And thank you, Patrick, for the demo. It was great. So I'm Sam, co-founder of Dagger. I most of my time I'm managing the engineering team at Dagger, and whenever I can to allocate some time to code, I try to help on some things that are blocking some users. And lately we had a lot of questions on how to use GPUs, in particular NVIDIA GPUs with Dagger. And not a lot of people know that Dagger actually has support for GPUs. It's currently poorly documented. We know that, and we're working on it. So you can expect some movement there soon. But I wanted to take the opportunity to show a quick demo, a live demo on how to use an actual GPU from a Dagger pipeline. So let's start with the problem we're trying to solve. In general, GPUs are expensive, and the problem is, even with containers, they cannot be shared easily. Meaning, when you allocate a GPU from a container, you basically mount the device, you rely on specific hardware, and it's very challenging to make it ephemeral, like you do with anything else with containers. And you're usually stuck with a piece of hardware that costs a lot of money, and that sometimes you need only for a small amount of time, not like hours or days. And so what I wanted to explore is a way to use a GPU from a Dagger pipeline only when you need to, right? So digging into the solutions. So on one side, you have my local machine on the left with a bunch of things. It's very simplified Dagger pipeline, linting code, running unit tests. And then maybe at some point I want to call an LLM. I want to do something. So in this case, I picked Ollama because it's a very simple way to demo. Relying on an LLM and doing some inference, simple inference, but obviously a real use case would be a bit more complex. And so that's what I'm going to show. But then on the other side, what's interesting is you have FlyIO that supports GPU, very easy to spin up a container, very simple to run Dagger on it. And you can also run, obviously, Ollama inside Dagger. So that what I'm going to show is basically how you can run this Ollama run right there at the bottom on and export it to FlyIO with the GPU attached. And I will show you a way. I will call that in the demo right now from my local machine. But what's important is I want to keep that secure, and so I'm using I'm talking to the Dagger engine from a VPN. So FlyIO supports private networking. It's a normal VPN using WireGuard actually. But anyway. And if you have questions, so I'll show you the live demo. If you have questions, let me know. So I will jump to the code. So here I have, I will share the code. It's all on GitHub right now. But the idea is I have a couple of functions. So here I'm running that locally on my machine. I did previously a simple Ollama run locally. So it's running in CPU on my machine. I'm using a prompt by default. I think I asked what color is the grass, something like that. But it's an argument with a default value that I can change. But here I'm interested actually to run that remotely. So you probably saw that there is a deploy Dagger on the fly. So let's call that and see what it does. So what I'm gonna do here is spin up a Dagger engine remotely on FlyIO and configure that instance to have access to a GPU. I actually picked a couple of things that can be changed in the code easily, but here I'm picking an NVIDIA GPU L40S, something very light, very cheap also. But technically, I could do the same thing with an H100 and etc. So this would work the same. The idea was just to show that Ollama has access to an actual GPU. So let's see what happens. It's deploying the machine, waiting on FlyIO to deploy it. And soon it should give me a result. So that result is actually an environment variable that I will copy paste, that I will export. What it does is I'm telling the Dagger client locally to talk to the remote Dagger engine that runs on FlyIO. It's an internal IP, so if you're trying to replicate that yourself, you won't have access to that machine. It's totally secure because I'm connected up there on the FlyIO VPN on my FlyIO org. So here now on that new machines, when I do a function, so the first one will be a bit slower because it's actually exporting my local context to the remote Dagger engine. because actually the nice thing I wanted here was to still keep my local environment and keep working on my Dagger pipeline and do calls that are actually executed remotely. So that's why it's taking a bit longer at first, and then the second calls will be faster because everything will be cached. Looking at so here we are. So the functions here and all the Dagger commands that I will run from now will actually be executed remotely on fly with the GPU. So let's try an Ollama run again. Well, let's give another prompt because I don't know what color is the sky. Maybe I don't know. I'm I'm not very creative for that kind of stuff. While it's doing it, I'm opening the graph on Dagger Cloud just to follow what's going on. So I have access to, I should be able to see roughly the same view on my terminal and the browser. So here it will execute the whole thing. So I will show you the code right after. But the idea, what I'm interested about here is the Ollama serve that will execute in a bit. And I'm interested to see what Ollama sees on the machine, if it sees the GPU or not. Actually, it should not for the first run, and I'll tell you why. And it's actually okay because we are caching a bunch of things also, including the cache from Ollama itself. Because by default, my code is actually using an image Ollama with CPU, which basically pulls the Ollama image from the hub. And I have an option use GPU that I will use right after that actually swaps the regular image and enables the support for GPUs. So I will compare both execution and see what happens. So here it's pulling the model, putting that in the cache. And the interesting thing about what's happening here is the cache here will be persisted. So I put that in a cache volume on Dagger. And so next time I call the model, I won't have to repull the model again. So let's jump to, I should see the result of the exec.
And for this is a beautiful UI, Sam. But for people who may be joining who aren't so familiar with Dagger, what is this?
Yeah, absolutely. So, sorry about that. So it's I should have explained. So it's showing Dagger Cloud and in particular the new V3 version that's actually much faster and much also has more features. So here, for instance, I'm showing you. So Dagger engine can optionally. I saw Patrick actually was using it as well in the last demo, but the Dagger engine can export telemetry to Dagger Cloud, and in order to show the whole graph of the DAG. So the idea is here I can see all of my local traces up. So the run that I just did, even though I did it from my local machine, I can see it on Dagger Cloud. And here I see the whole DAG. So the whole thing I see from the code in Go here. Right there, I can actually see the representation on right there on Dagger Cloud, and I can navigate the DAG. So here, what I'm interested about is I executed an Ollama server and a client, and I'm interested to see if Ollama saw any GPU. And here I can see that no GPU were discovered, and that's normal because I'm using the normal Ollama version. So by default, it's running in CPU. But now I'm going to rerun that again and show you what happens when, sorry, swap, moving to another. I will pass the option use GPU. And so it will run the same thing again, but it will just rebuild the base image before running it. To show you what happens also if you're not familiar with a Dagger pipeline, I'm running two containers here. I'm running a server and a client. Actually, let me just open Dagger Cloud on the side. So yeah, here, sorry, I'm switching between because a lot of things is happening right now, but what I was interested about was to see the Ollama pool, so grabbing the model weights is not happening again because it's being taken from the cache. But the part that I wanted to show you is the server is running as a service. So I'm running the server, mounting the cache, running Olama serve in a container, and then using a client, bind the service to the host name Olama internally. So there is a private IP with a DNS name just accessible to that container right there because I'm doing the service binding, and instructing Olama to connect to that host. And then I can run Olama command here. And my prompt, etc. I could be running several other things. And then I return the results of the prompt on std out. So it seems to be a pretty simple pipeline, but there are actually two containers talking to each other and being synchronized to make sure that the client will talk to the server only when the server is ready, etc. And then once the client finished doing its job, the server is being brought down and I get the result back. So all of that was executed remotely. And the part that I'm interested about, right before I was showing to you what's the result, what's the log of the Olama server, and I'm going to look at it again just to see the difference from the previous run. So it's loading a bunch of logs right there. Okay, I see the call from the prompt at the bottom, but what I'm interested about is what's happening right there, looking for compatible GPU, and look at that. Here I see Olama actually discovered the L40S, the NVIDIA L40S that I exposed, that I have accessible on the FlyIO instance. So I can do proper inference with Olama and something else. And so basically the prompt was executed, was called by the model on the GPU instance this time, processed by the GPU. And going back to, well, I showed you the code. Yeah, one actually thing I wanted to show you also is I don't want to pay for that GPU anymore because I'm done, you know. So I will just grab the name of the FlyIO app, and what I can do is I can just simply destroy that instance when I'm done. And so I'm doing it now. And as soon as this completes, I'm not paying for GPU anymore. I just released the resource. So I can do my work. I can do my deploy the instance, work on my Dagger pipeline, and bring it down at the end. It's taking a bit some time. I deploy the app. Should complete soon, I guess. Should anyway. Going back to the slide at the end, I just wanted to say a few more things. The next step is to remove the manual switch. So basically what I'd like to do next with this demo, you can look at the code on GitHub already and see if you can if it can be useful for you. It's a basic example that you can reuse to actually rely on NVIDIA GPUs for anything you want to do from Dagger. The part that I'd like to explore next is how to export Dagger node directly from a live pipeline, meaning I have a pipeline that runs my linter, that runs my unit test, and at some point I have one single step or a few steps that need a GPU that then can be exported remotely and go back to the rest of the graph. So that way I can run my CI pipeline and not rely on a GPU for everything, just for the thing I need. So I'll be exploring that in another demo. If you have feedback or things you would like to see as well, let me know. And also, last but not least, I wanted to say a big thank you to Gerard Lazou for the Dagger module. He gave a couple of demos in the past during this call, and there is this module on the Daggerverse you can reuse for having a remote Dagger engine on FlyIO, and also you can configure it so you ask for a GPU as well and a particular model. And also big thank you to Rajat Jindal, who helped debugging the GPU support. We had some issues to make it working properly initially, and And so, yeah, just wanted to give credit to both of them. And that's it. Thank you
Thanks.
for listening.
That's a super awesome demo and presentation. And I think for people who have a lot of questions on this, I'll make sure to add this, the snippets to a lot of the GPU threads that we have in our Discord. But for people who have, either more questions or you're trying out something similar and you're getting stuck, it's just a reminder, like the Discord is a great place to be because there's a lot of people who are doing similar things. And then like Sam said, Gerhard and Raja are also in the Discord, and so asking questions there, we can always lend a helping hand when you need. So, but yeah, this is really cool to see, and so excited to see all the improvements being made here too, and the documentation that's coming soon.
Of course, yeah. That's something we're working on. We need to document better the GPU support, but now at least we have some repeatable code that we can document and share with everyone.
Yeah, this is great. Perfect, and I'll add the link to that GitHub in our Discord too, and as a comment also, so people can easily access it. Let me check if there's any questions. I don't think so. No, perfect. Thank you, Sam. And
That's really cool.
Yannick, did you want to share your screen? Let me go.
Yes.
And before you get started, I do want to do just a quick shout out to the Puzzle ITC team, because not only are they're going to share kind of how they use Dagger today, but they've been an amazing partner for us. And so I wanted to shout all of you out because they're based in Switzerland, but they do consulting. And so what's been great about them is they've not only given us great feedback on Dagger because they use us, so they can give us that actual feedback, but also they've been really helpful on consulting users on if they need support on how do they integrate Dagger into their pipelines today. So if you're someone who's looking for that, I just want to make sure people know of them as a resource, because the team is awesome. They're all super super nice, but then also really know what they're doing with Dagger. So just I want to give that shout out before you begin. So anyways, go for it, Yannick.
Thank you, Miranda. So welcome everybody. Today I'd like to show you our journey into the Dagger engine hosting space realm, and maybe first of all to give you a bit of context. As Miranda told you, we use Dagger and we'd like to use Dagger even more. We also use Dagger since before the pre-Zenith era, so maybe some I don't know if you know, but Dagger didn't have modules at the start. In the first iteration, it was Q, I think. Then there were the SDKs, which you had to use to start the Dagger engine via the code, and now you have the modules. So we use it since the SDKs, and this also showed up in our infrastructure that we have today. Maybe also for the context, I work as a platform engineering at Puzzle. I also work as a platform engineer in the CI/CD team. So my day to day is making sure that our CI/CD infrastructure works, and with that also that the Dagger engine works. Here we at Puzzle, our developers like to use GitLab CI/CD. We use the GitLab CI/CD operator running on OpenShift. And with that, we also use the Kubernetes executor. This is all really specific for GitLab CI/CD. The Dagger engine itself also runs on OpenShift. We are using currently the official Helm chart. And everything that you see on this slide is tied together by Argo CD, our GitOps setup hosted via Argo CD. We really like to use the declarative approach to manage our infrastructure. And Argo CD gives us that. So the Dagger engine on OpenShift. First of all, I have to say the official Helm chart of Dagger is really, really nice. So it's a good quality Helm chart, and we also used it a lot. But we have some problems when we want to run on OpenShift. maybe you know OpenShift uses ASCII Linux under the hood. The nodes of the OpenShift cluster use ASCII Linux, and a big problem for us as the CI/CD team is that usually we don't or we aren't cluster admins. We don't have the cluster admin permissions for the OpenShift cluster. So we rely on the operations team that is responsible for our OpenShift clusters to run. And yeah, to run Dagger engine, you have to set up security context constraints. We also sometimes encountered some problems with garbage collection. So some of our builder nodes that are used for the Dagger engines ran full. And then we had to write a ticket or something or chat with the OpenShift team to help us because we don't have access to the nodes themselves. So they have to clean up for us, which makes the management a bit hard for us too. And overall, I would say privileged workload on an OpenShift cluster or on Kubernetes, plain Kubernetes even, makes sometimes managing deployments, especially the daemon set for Dagger engine, a bit hard. So what are the possible solutions, or what did we consider to maybe help us find a better way to host the Dagger engine? So first of all, we tried confidential containers. This is a container runtime which makes it possible that you can run pods. The smallest compute you have, the smallest type of compute you have on Kubernetes inside a virtual machine. The problem with confidential containers is that if you want to run privileged pods, you still have to use a SCC, a security context constraint, to run privileged workloads. So didn't really help us, sadly. We also thought about externalizing the Dagger engine to a virtual machine, which would give us much nicer control overall for the Dagger engine. We sometimes do this for build infrastructure because maybe the caching distribution is not quite right for us and makes the pipeline even worse. So we maybe centralize it to a special server which has really power to do the builds. Yeah, that's one strategy, but we had some thoughts about using virtual machines, and for us, we like to use OpenShift. We like to work on Kubernetes. So we would really, it felt for us like a step backwards. And also we sometimes maybe want to use bare metal nodes. So we also maybe want to integrate some bare metal nodes in the future. For us now, the current solution is we use KubeVirt. So KubeVirt is a CNCF hosted project. It's part of CNCF since 2019. The current state is incubating, and it can be used to run or to manage, better said, to manage virtual machines via the Kubernetes API. So you can integrate virtual machines into your Kubernetes stack with it. And the virtual machines are running in pods, so to speak. Of course, under the hood, they use the KVM hypervisor, and the processes start a QEMU process to interact with the KVM hypervisor on the node, but it's really well integrated into the whole Kubernetes ecosystem. Here, a small example of how a virtual machine instance manifest looks like. I know YAML files are not that nice to look at, especially in presentations. But what's important here for us also was to use the container disks. When you use a container disk, this is a special type of disk you can mount to the virtual machine, which makes the virtual machine, if this contains, for example, Ubuntu, which makes the virtual machine an ephemeral virtual machine. That means if the virtual machine has to restart, it more or less behaves like a normal pod, and or in a deployment, when the pod will get recreated. So if the VM will restart, it will be recreated instead of rebooted. And yeah, you can also mount, for example, here empty disks, which work a lot like MTDIR, or you can mount persistent volume claims, so you can pull in storage from the network, or you can pull in local storage. You are really free to use whatever you want and whatever you need. Also, the Cloud Init is supported too, so we can use Cloud Init to bootstrap our virtual machine. The second part, which would be integrated into the first YAML file, it's as the Cloud Init disk. Here is this Cloud Init file, which will install Docker as a container runtime, and then install or start Dagger. It will also mount a volume where Docker can store the containers and everything that Docker will pull, and the volumes Docker will create. You can also mount a second disk, for example, to externalize the varlib Dagger directories, the working directories for the Dagger engine if you want to. Yeah. So our new setup looks a lot like the setup described in the official Dagger docs, but instead of using a daemon set, which is installed via the Helm chart, we use a virtual machine, which in turn creates a virtual machine instance. And we also make use of the multiple persistent volumes. The most important volume for us is the varlib Dagger, which is a bit bigger than the containers directory that I showed before, or should be a bit bigger than the containers directory. Here you can see the runner creating jobs, which are scheduled as pods on Kubernetes. This is special for the GitLab runner. And the jobs will connect to the Dagger engines we can run via a service, a Kubernetes service, and this is done via TCP at the moment. And the TCP, we don't use MTLS at the moment, but we have a network policy in place which makes it possible to only connect to the Dagger engines in the same namespace. So you don't have access from another namespace to the Dagger engine at the moment. And yeah, so we're really interested to see how fast TCP is or how slow TCP will be. Gerhard Lasu did a talk on the first Dagger meetup in Switzerland, which was really interesting when he compared the speeds of the transports which are supported. So yeah, we'll see. At the moment we will use TCP, but with this setup it will be also possible to host a GitLab runner inside the virtual machine, which also hosts the Dagger engine. So we could possibly connect via socket to it if we to the Dagger engine if we want to. But yeah, we'll see how it scales for our needs. Another thing, the GitLab CI/CD integration. So on the left-hand side, you see our old setup, which had some reminiscence of the pre-Zenith ways. I'd say the pre-Zenith era of Dagger. Here is a Dagger Python image included, which also bundles the Python SDK, which was used before to connect to the Dagger engine or start up with the Dagger engine. And we also didn't really abstract away the Dagger host environment variable. But now with the new setup we have in place, our developers only need to use a Dagger tag and everything is set up for them. So they can just use Dagger call and call their modules. And yeah, the caching will take over from the Dagger engine, but also if they need some more integrations, they can still do everything that they want into GitLab. But yeah, most of our developers just like to call Dagger call and be done with it. So this is now a really small script instead of having to include. So even before you had to include a template, and now we just can choose the right tag. Yes. So now I'd like to show you a small demo. For that, I created here a small CI pipeline in GitLab CI, where we just print out the Dagger version of the Dagger CLI. And yeah, of course, Gerhard is also the kubeproxy since, yeah, we will see. We are stress testing the setup currently, but I hope it will behave correctly and not be overwhelmed. But yeah, we print out the Dagger version, and then we have two jobs that will print out the OS release contents of first of Alpine and also of Ubuntu. And if this job or pipeline runs, so for example, this run is from one before the talk here. At the moment, it's in the version 13.7, Dagger Engine 13.7. But when I go back, then here in the test Alpine, for example, it's just a sample output. So you get a feeling what it's outputting here too. We get the name Alpine Linux, all the OS informations. So as I said, we managed the setup via Argo CD. Here you can see, I hope it's big enough. Here you can see our resources that are relevant to you. We have a lot more, 19 additional resources, but these resources are, for example, secrets to connect to our registries we have set up there too. Not really interesting now for this talk. But here you can see the runner, you can see the service. We use a virtual machine pool, which is another type of manifest provided by KubeVirt, which ensures that we can scale up the number of virtual machines we want to have. Also, if we want to have multiple Dagger engines running in parallel, we can just, as you know from the deployments in Kubernetes, you can just set the replicas to a number 2, 3, whatever you want, and it will make sure that you have this number of virtual machines running inside the cluster. And the virtual machine spawns a virtual machine instance, and this instance has two persistent volume claims. One is for the container storage. So when Docker pulls the containers, it will save them inside this persistent volume claim. And the second one is the Dagger warlib Dagger directory, which is mounted to this PVC. And for us, before we had some problems upgrading because the privileged workload, and now I'd like to upgrade to the newest version of Dagger. So I will create, maybe I have to say, here this is the deployment repository. We bundled everything that you've seen in Argo CD. We bundled everything inside a Helm chart and tried to create the Helm chart like the official Dagger Helm chart. So we only have to in the best case, we only have to update the app version here, and everything else will take place automatically. So I commit the changes, and I will force a refresh here, so we don't have to wait until Argo CD will pick the changes up. And now you see the Dagger, the virtual machine will get into a succeeded exit, and now it's recreated. So we recreated the virtual machine instead of reboot. So what does mean? That does mean that the virtual machine instance will run through the cloud init again, but because everything that's state related is outside of the virtual machine and mounted into PVCs, it won't get touched. So it can just reboot and apply the new Dagger engine. We also have a health check here. So when this heart will be green, the Dagger engine running inside the machine is accepting TCP connections, and we could run again. We can run the jobs again. But
yes, the kubevert is really, really cool. I also especially like the cloud init part of it.
yes,
Maybe while it's running, what is the health check do, or like how does that determine the engine's ready?
it just listens to the port from outside. So we could actually just display, maybe you see or here, maybe we can see it here. So the health check is more or less just, so here is the readiness probe, for example, but the health check, the liveness probe is the same. We just try to connect to the TCP socket port 2375. And this is the one that the Dagger engine also binds to inside the virtual machine. And if it's up and running, yeah, it will answer to it.
Awesome. Yeah, that's really nice.
So at the moment, this virtual machine only has like 4 gigabytes of memory because we're just a bit trying out how much memory we'll give it. In the docs, yeah, it will probably in the production, it will be like 8 gigabytes of memory and 4 CPUs. But now we are just trying out some stuff with this setup. Yeah, we'll see where we land. And yeah, the boot takes more or less 1 or 2 minutes, but I can switch back for it to the presentation, to my last slide, without actually presenting it. Yeah, what's next for us? At the moment, we're using Ubuntu. We'd like to try out using a container Linux distribution like Flatcar, or maybe CoreOS or Fedora CoreOS, because we don't really need a whole Linux. We just need a specialized Linux to run containerized workloads, no overhead, or not that much overhead. Also, shared cache is a subject of the next steps. For the next steps, we dabble with the idea to create an operator to abstract away even more of the operations part. And yeah, we'd like also to extend the official Dagger documentation with our cloud init scripts, maybe, so other people of this community can host their Dagger engines onto hyperscalers or wherever they want to inside virtual machines. Thank you, Andreas. Any plans on centralizing caching? Yeah, that's one thing. We would like to centralize caching, maybe using the official Dagger cache, but maybe also some cache inside the cluster. But we're not sure at the moment how we go about it. We will see. Yeah. So yeah, stay tuned. We would like to create a blog entry in our official blog, maybe in February 2025, maybe a status update, how this setup really works. Is it good, or did we just change again to the Helm chart? Maybe, I don't know. We'll see. And yeah, also another reminder, if you are in Switzerland, please visit us at the next official Dagger meetup, which will be March 5th, 2025. Yeah, let's see if the engine restarted. Yes, it did. It has a green heart, so the readiness probe is working. Maybe I have also to cheat a bit because the GitLab runner doesn't really restart automatically, so it will have the old CLI installed there. So I will delete this deployment of the GitLab runner. So we have the newest configuration mounted there too. Just waiting a bit so it becomes ready, and then we'll push out the pipeline again and see if the update has worked. Nice.
That's great, Yannick. And I think I have I might start a new thing for community calls of where I do a tally of how many tools we can use with Dagger.
Yes.
All has the most tools, because seeing kind of how this all integrates, and and it's a great reminder too of just like you don't have to rip and replace with Dagger. You all had a setup, and you didn't have to have a whole conversation of like now we have to use just Dagger. We can actually integrate it into your current setup and improve things overall versus just rip and replace. So this is very cool to see, and like Gerhard said, very excited to keep improving this with all of you too.
Yeah, I'm very happy too with the setup. As you can see, it's now upgraded. So for us, the maintenance will hopefully be a bit easier in the future with this setup. But yeah, I hope you have seen some cool stuff. Yeah, you can reach us in the Discord too, I think. And yeah, if there are any more questions,
Awesome.
please shoot them at us.
Thank you so much. And yeah, I think most of the puzzle team is in the Discord. So if people have questions on this, I will add it to our demo forums. If you are in our Discord already, we have a whole forum section with links to all of these specific demo snippets that we'll put up in a few days. But obviously all of you can see the live recording today. We'll put it in there. We'll tag the speakers, and that way, if you have any follow-up questions or need advice on how to do something similar to what the speakers did today, you'll be able to ask them directly there and get some feedback. So thank you, Yannick and Patrick, so much for joining us today. I know Sam had to run, so I didn't say thanks to him, but thank you again to everyone who's also been working on improving the GPU experience too. So thank you everyone who's watching for staying longer. We really appreciate it, and we hope everyone has an amazing day.
And thank you, Brandon, for hosting.
Thanks.
Thanks, everyone.
Thanks, everyone.
Thanks, everyone. Thanks for having us.
Bye.
Bye.
Thanks. Bye.
Bye.